Okay, dear students, so let's see what is there in this question. The diagram shows two parallel conducting plates that are positively charged, that are oppositely charged. Sorry for that. So the upper plate is positively charged and the lower plate is negatively charged. Draw the electric field lines due to the charged plates. Draw the electric field lines due to the charged plates. Yeah, so electric field lines within the plates, we have to draw that. So we already know that the electric field lines, they always originate from the positive charge and they end at a negative charge. And whenever we are having these two parallel plates very placed very near to each other, that is a way of creating uniform electric field. So how are we going to create the uniform electric field? All the lines that we are going to show here, they should be parallel. By the way, you can show it like this also, there is no problem, like you can show it anywhere, okay, but they have to be within the plates. So it will be like this is uniform electric field. It is shown with parallel lines, equidistant lines, so they should be at the same distance, but at the edge there can be the edge effect, so you can show it like this. So this is known as edge effect. Edge effect. So what happens when you have these kind of parallel plates put together? You definitely create a uniform electric field there, but at the edges there is a bit of uniformity, non-uniformity, so that the electric field is bending a bit at the corners. So this is how we draw it. This is the electric field line. Now let us see what is the answer that is given in the mark sheet here, mark scheme. Equally spaced arrows by eye. Yeah, by eye means that need not to be 100% measured, all pointing downwards. Edge effect also shown with the arrows, so we have shown the edge effects also. So this is how we do this question. Now moving next. So this is the second question. The potential difference between the plate is given as 960 volt. The distance between them is 8 millimeter. Calculate the electric field strength between the plates. So there is a very good formula which is kind of like very popular and very important. I think that is given in the data booklet also. So there is a relation between the potential difference. Now, what do you mean by potential difference, first of all? So this plate is maintained at a positive potential. This plate is maintained at a negative potential. We can just imagine that they are connected with a battery like this. So this is negative, this is positive. So the upper plate becomes positively charged and the lower plate is becoming negatively charged. And the voltage here is V. So what is the job of a battery? The job of a battery is to create a potential difference between the two plates. So it is maintaining the potential difference, that is V. So this is positive here and this is negative here. So this is already done. Now, so the potential difference is given as 960 volt. And what is the distance here? So the distance here will be 8 millimeters. That is the distance. Now, what is the formula? E is equal to V by D. So the voltage is 960 and D is 8 millimeters. So it will be 8 into 10 raised to power negative 3, which is equal to E. That is the electric field that it will be there. We can just solve this equation. Always be careful about the units here. This is 8 millimeter. It has to be converted into meters, and volt is the SI unit, so there is no problem with that. We just plug in the value, we solve it, and we get the answer. So let us see what they have done in the mark scheme. Absolutely the same thing. E is equal to V by D, and V value and D value is given there. So you are getting the answer, which is 1.210 raised to power 5. Newton per coulomb is the unit. Always you have to write the units with that. Only numeric values are not good. So you have to give the unit also. So this is the electric field intensity or the electric field strength between the plates. Now moving next. In an experiment, an oil drop is introduced into the space between the plates through a small hole in the upper plate. The oil drop moves through the air in a tube before falling between the plates. So let me show you the diagram here. This is what is happening. So this is these are the two plates here, and so of course the electric field is created, which is the value of the electric field was 1.210 raised to power 5 Newton per coulomb. and the oil drop is falling from this tube, which is clearly written there that it is falling through the air. It is introduced in the space between the plates through a small hole. The oil drops move through air in the tube, so it is crossing through air there. And the question is, explain why the oil drop becomes charged if it falls through the tube. So the oil drop is getting charged. So we assume that initially the oil drop was not having any charge on it, but when we drop it, so oil drop is falling through the air, and at the moment when it is entering into the plate, it is having some charge on it. It has accumulated a charge. Like, from where is that charge coming and why is that charge coming? So, in the theory classes, or if you might have watched my videos for the lectures, I've told you there are three methods in which the particles can be charged. So, the first method is the method of friction. That thing is also known as frictional electricity. So, there is this particle here. This particle is falling through the air, and the air is causing a bit of friction there, and because of this friction, what happens, the electrons are getting exchanged in the two bodies. What are the two bodies here? One is the oil drop, another is air. So when the oil drop is moving through the air, because of the friction, the electrons are exchanged between the air molecules and the oil drop. And of course there is a bit of charging there, so one out of the two is having surplus electron, and the other is having a deficiency of the electron, so that will be positively charged. With the surplus electron will create a negative charge. Accordingly, the drop will be charged. Explain why the oil drop becomes charged if it falls through the tube. So we have explained it, that because there is friction between the drop and the air, and because of the frictional electricity, the electrons are getting transferred from one medium to another, thereby charging the oil drop. So it's one mark question. So you can just write one single line, there's one single point there, and that should be giving you the exact score. Like, the friction transfers electrons from to or from the drop. You clearly see they have written one statement here: friction transfers electrons, but they are still not confirming whether it is to the drop or whether it is from the drop. As I told you that we have to think of it, we can think of it. We know that it is going to be, I think, negatively charged, so it will be accumulating the electrons, so it will be gaining electrons. So literally electrons are transferred from air to the oil drop, but we cannot still say it. That is why you are just saying that electrons can go from the drop also, they can be given to the drop also. It's like that. But I know that electrons are transferred from air to the oil drop. So drop is becoming negatively charged overall. But let me show you why and how. We are going to discuss it later. The oil drop is observed to be stationary in the space between the plates. Buoyancy is one of the forces acting on the drop. Now, the situation becomes even bigger. Now what is happening, like, let's say these are the two plates here. So there is this drop which was moving. Now it was going downward because of its weight, it was falling through the tube. But as soon as it enters the region of these two plates, it is seen that the particle is not moving now. Neither it is going down nor it is going up, but it is levitating inside the plates. Now the question is, why is the drop levitating? Of course, there has to be some forces, they will be acting on the body. What are those forces? So let's say this is the medium here. Of course, it is air. It's not a vacuum. And the air drop, when it is put in air, the oil drop is put in air. Of course, there will be a buoyant force which will be acting as an upthrust on the particle. So there will be the upthrust here. So one force which is acting on this will be the buoyant force. We are going to see that because they have already talking about the buoyant force now. And there will be another upward force, and the upward force will be the electrostatic force, isn't it? Because like the upper plate is positively charged, this is negatively charged, we can say that the particle is negatively charged. So there will be another force which is the electrostatic force, which is in the upward direction. Again, you might be asking, like, how can I imagine that it will be negatively charged and there will be a force which is in the upward direction? Let us see it. because like I've done this question earlier, so I know the further detail. I've done that question in my classes earlier. Okay, so the question is, show that the buoyant force is much smaller than the weight. So the upward force of the buoyancy, that is much smaller than the weight. How can we show it? So the weight will be written as m into g, and this mass can be written as volume into the density of the oil into the gravity. That will be the weight, because we want to find the mass of the oil drop. And there is the buoyant force, and the buoyant force, it goes like the volume and the density of the air into gravity, that is the buoyant force. So if you don't know what is the buoyant force, again you have to go for the theory part. There are lectures available on the YouTube channel, but I think this is the topic A2. So you have to become the member there and you can watch this. So the buoyant forces are, they are like written with the V is the total volume which is sinking, sigma is the density of the medium, not the oil drop. It is the density of air, the medium in which the drop is falling, and the gravity. This is the point force which is there. Now it is written that the density of oil is 730 times greater than that of the air. So in the point C we have the density of the air, but here it is 730 times. So you can just write as V into G into 730 times sigma, and this will be V sigma G. So V sigma G. So clearly we can say that weight is nearly 730 times bigger than buoyancy. So of course we can neglect the buoyant force there. And that is what is the question, like show that this is very small in compared to weight. Now I told you that there will be the electric force there, and why there will be? Because there is no other force which is going to cancel the effect of the weight. There is no upward force. The only force is buoyant force, and the buoyant force magnitude is much smaller than the weight. Of course, the buoyant force is not enough and it cannot stop the drop from going downwards. So there has to be another force which will be working there, which will try to stop it, and that will be electrostatic. And it has to be in the upward direction. That is why the drop is supposed to be negatively charged, because otherwise if it is positively charged, the negative plate downwards will start attracting it. So of course it cannot levitate. So we can just imagine that drop will be accumulating negative charge. But let us move to the next question and see what they want to ask. They have literally done the same thing. They are just showing you the ratio of the force of the buoyant force and the weight. So we have done it exactly in the same way. Draw the forces acting on the oil drop, ignoring the buoyancy force. Now the buoyant force is neglected, and we have to talk about all other forces which might be acting on the drop. So according to me, number one, the drop, the weight is acting there, and number two, the electrostatic force should be acting there, and acting on the oil drop. They have not mentioned when is this happening, because if you talk about the tube, there will be no electric force, but there will be viscous force, which is given by 6 pi eta rv, because it is moving with a certain velocity. But if I talk about the moment when the drop is inside the plate, at that time the velocity is zero, because it is literally levitating and the particle is at rest. So the drag force will not be there. Instead of that, the electric force will be acting on it. But now what they want us to do, that is not pretty clear in the question. We have to see the answer there. So the weight is vertically down, and they're talking about the electric force here, equal by the I, because they are canceling each other. So I can say this is the weight and this is the electrostatic force, yeah, which we thought earlier. So we need not to talk about the viscous force as of now. Anyways, so and the magnitude will be almost equal to each other. Why? Because they are canceling each other. Okay, so this is done. Show that the electric charge on the oil drop is given by this value. Now we have to show that the electric charge that has been accumulated is this. So of course, like I can just see the equation here. I can just guess Q, like E goes to the other side, it will be QE. So literally, they're talking about the electric force, and V rho G is, of course, the weight. So we are just balancing them out. So in the diagram here, we are drawing the upward force and the downward force with equal in magnitude. This is Fe and this is the weight, and so they will be equal to each other. So weight is m into g, and Fe is the electrostatic force, which will be given by q into e, and the mass m will be the volume of the drop and the density of the oil drop. So you can write density O. This symbol is rho, and it is usually used to show density. So it is V rho naught into G, that is equal to Q into E, because it is levitating and the forces are balancing each other. From there, you can clearly find the charge on the drop, which will be V rho G divided by E. And that is what we wanted to show. So everything is, of course, we can understand this like this. Okay, so this is how the C3 top point is over. Let us move to the other part. State the sign of the charge on the oil drop. So after all, they are indeed asking you the question like what will be the charge on the drop. So we can clearly see that the charge on the drop has to be negative. Why? Because otherwise, why there will be the electrostatic force in the upward direction? The upper plate is positive, the lower plate is negative. So if the charge is not negative, how can there be the electrostatic force which is in the upward force? So that of course will not be happening. So this charge particle will be negative, it cannot be positive. So this is clearly wrong. So we will say the oil drop is accumulating the negative charge. I hope you understand. It's 1 mark question, so you just have to write one statement there. Let's see what they are writing. Negative, nothing more, no explanation why negative. They're not talking about that, only negative. And try to see the question. State the sign of the charge on the oil drop. The question is very straightforward, so your answer has to be as straightforward. State the sign, so the sign will be negative, no doubt about it. Okay, so the question is very long. Let's discuss what is there in the D. The electric field is turned off. Now there is no electric field that we're considering. The oil drop falls vertically, reaching a constant speed v. Now we're just imagining that the gap between the two plates is too much. So do not imagine that by that time the drop will be falling on the negative plate. So we are not considering that situation. So drop is always falling, and it is not falling on the plate anytime. So outline Y for this drop, rho Vg is equal to 6 pi eta Rv, where eta is the viscosity of the air and R is the radius of the oil drop. The oil falls vertically, reaching a constant speed of V. My dear students, we have to read the question very properly. Every statement is having a link. Every statement, there is a reason for that statement to be sitting there. So we have to read those statements very properly. Electric field is turned off, so electric force is not there. Oil drop falls vertically, of course, under the effect of weight. But if the weight is the only force, then the velocity will always be increasing because the gravity will be there, acceleration due to gravity will be there. But it is reaching a constant speed. It means they're literally talking about the terminal velocity. Now the terminal velocity. So rho naught g capital V, this is the weight which is acting downwards. And now there is another force which is viscous force. You can also call it drag force. The drag which is on the drop by the air. So you can call it drag force or the viscous force. So that will be 6 pi eta Rv is the drag force here. The weight is mg. So we would be balancing these two. So after some time, like we know the topic of terminal velocity, we just balance these forces, we find the velocity. This velocity will be known as terminal velocity, the velocity at which both of these magnitudes are equal to each other. Now the question is, outline y for the drop. This is equal to this, where eta is this. So we will say that because it is given in the question that it is now moving with a constant velocity, so the net force must become zero. It means that there should be an equal and opposite upward force to the downward force, and they should be cancelling each other. and then only it would be able to move at a constant velocity. So definitely they're talking about the terminal velocity, um, and in that situation, the both of the forces, they are equal to each other. That's it. So the net force is zero. The acceleration of the drop is zero. For the terminal velocity, the drag must equal the weight. So how much mark? Like 2 mark question is this. So you can just give two statements there somehow, and like net force is zero, acceleration of the oil drop is zero, like that. So we have just done that. Now I show that the charge on the drop is about this. Now you have to find the charge Q. The following data of the oil drop is available, and you have to find the charge on the drop. The charge on the drop. How can we do that? Because when the charge is there, the viscous drag force is not acting on it. Okay, how can we do it? I don't think there is anything that we can do. Let us go for the mark scheme. My God. Now, let me tell you one thing. Q is equal to this. Now, what are they doing is that they are just equating the upward force with the downward force. Upward force with the downward force. Now, the upward force is created in the electric field, and the downward force is created. Well, no, no, no. They're not equating the downward force. They are equating with the drag force. What the hell is this? Okay. I understand that now. Okay, it's a very tricky question, very beautifully placed, I would say. Commendable. Very good. But okay, let's say there are two situations. One situation is when the electric field is working, and at that time it is levitating. So mg will be equal to F into E, isn't it? Because this is the point when the electric field is working and the point is levitating, which is the case number one. So I can clearly say that mg is equal to Q into E. Now, in the second case, they are saying that the electric field is not working anymore, but it attains to a constant velocity. So at that time, the upward force becomes the viscous force, and even they are equal to each other. So from the second case, I can say that mg is equal to F into V. So that is the second situation when the electric field is not working. Like, I was so confused. I thought like that in one situation the electric field is there, and we would be talking about electric field. In another situation where we are talking about the viscous drag, there is no electric field. So how will we be able to create the equation? That's a very tricky part of this question. Very good. So from one case we are saying that mg is equal to qe. Another case mg is equal to F into Fv. That is the viscous force, or you can say the drag force there. So very cleverly, we have created the equation that is QE is equal to 6 pi eta RV. I'm just writing VT here because I just want to tell you that this velocity has to be the terminal velocity. Otherwise, it is not going to be the case. So they have not mentioned it anywhere. They have just written the velocity is this, but they have not mentioned anything. But earlier they said that because this question is connected to D1. So they're already saying that the particle is moving at terminal velocity. So we can just imagine that this is the terminal velocity. So our conditions are valid. We can just plug in the value and get the answer. So this is very beautifully done. Q is equal to 6 pi eta RV into E. Okay, my God, I was just highly confused there. Like, what the hell? But very good. Because yeah, their questions are very good indeed. No doubt about it. Okay, so D2 is over. And ironically, they have given the answer in three significant figures. And I don't know why they have done that. Okay. I tell you. Okay, this is like they are just saying that the answer is about this, but the calculations are to be done according to this. So here they have intentionally chosen three significant figures every time. So the answer will be in three significant figures. Be very careful, my dear students. Why? Because usually IB is happy with two significant figures, and that is why, like, I thought that it's given as 4.8, so they will be interested in two significant figures. But because the calculations, like the values here, they are in three significant figures, so your answer should be in three significant figures. Yes, you can round it off and you can write this also, but I believe your answer should be given like this. So this is your true answer, but you can round it off later to two significant figures if you want. I think this is it for the question. Oh my God, one more question is there. The oil drop splits into two parts of equal mass. Both are charged. Deduce the net charge on each part. Again, that's a too tricky question. Okay, it's a very tricky question. And IB is asking this question time and again. They have asked this question many a times. This question is from the quantization process. Let us see. So, what is the principle of quantization? So, again, this is the part of the theory. If you have seen the lectures, you might be knowing it. So, Q is equal to N into E. That is, like, this is the quantization principle. It means that if one body is getting a charge of Q over all, so there will be these many electrons sitting there. So N is the total number of electrons there, and E is the charge on one electron. So Q is equal to N into E becomes the total charge. The condition here is that charge cannot be lesser than the charge on an electron, because electron is supposed to be indivisible. Yes, today we can divide electron into quarks and others. No, not quarks, sorry. uh, no, I'm sorry for that. Electron is not divisible, yes. So electron is definitely the minimum negative charge that you can say. So, so we would be transferring electrons because of the friction and everything. So whenever a body is getting charged, it is because of transfer of electrons. Electrons will always be in integer number, like let's say 5 electrons or 10 electrons, but you cannot say that I have given you 9.5 electrons. From that concept, we have created the concept of quantization of electric charge, where n got to be an integer. So it will be 1, 2, 3 like that, but it will always be an integer. Now, in these kind of questions, there is a procedure that we have to follow. This is the total charge that you were talking about. So we first try to find the n value there. How many number of electrons are there? So total charge divided by the charge of electron. See, usually what students do, they don't follow this procedure. They just imagine that because the drop splits into two equal parts, the charge will go half and half. But I will show you why the charge cannot go half in such cases. This is the total charge on the drop, and you divide it by 1.610 raised to power negative 19. So something is happening here, isn't it? Like, what is this value? 4.79 divided by 1.6. I am literally getting 2.99. So we can just imagine it to be 3 electrons. So there are overall 3 electrons in the drop. Now you are dividing this drop. Of course, you cannot divide the electron. It means that one drop will end up having 2 electrons, and another drop will end up having 1 electron. Getting my point? So one drop will be having 2 electrons, another drop will be having 1 electron. This is how we divide these particles. And of course, they are not having equal charges, because otherwise it could be 3e by 2 on both sides, but that is not happening. So 2 electrons on this side, 1 electron on this side. This is how we do this. So whenever IB is going to ask you this kind of a question, this is the trick every other time. And they have asked this question so many times now. So you can be expecting one such question. Yeah, the charges must be 1e and 2e. Charge is quantized. That is the reason. And the question is over. There is no other connecting part. So this is how we do this question, my dear students. So we have completed that. I hope you have understood each and every part of this. This was a very long question indeed. It was talking about the topic D2, and it was having the concept of energies. So you can say that it was connected with the topic A3 also, and it was connected with the A2 also, which is the point forces. Yes, it was connected with A2. And yeah, it is not connected with the energy thing, I think. Yeah, there is no energy part. And the last part is again connected with D2, that is the quantization of electric charge. Okay, dear students, I hope you have enjoyed the video. This is Professor Varun. Keep learning, keep watching. All the paper one question walkthroughs and all the paper two question walkthroughs are now free to watch. All the best.